2.4 Adaptations of the Body by Tom Hopper. For this presentation, I'm basing it around football and showing the different types of adaptations, whether they be anaerobic or aerobic, how they can improve your overall performance. Football requires the anaerobic side of the body, like when you sprint for the ball or take a free kick. However, you need the aerobic capacity when the ball is down the other end of the pitch, and you need to take a breath to generate ATP in the body to have more energy the next time you have to go for the ball. To begin with, the anaerobic training could be something like a long distance run to improve the aerobic capacity, and I'll be using the FIT principles, which stand for the frequency, which is the amount of times you do it, and to improve your aerobic capacity could be done 2 to 3 times a week. The intensity, and for aerobic it would be a low intensity, and then the time, which would be for about an hour of slow jogging, and then the type would be the slow jog, which again increases aerobic capacity. This will help football, as having a good aerobic system means that you have more alveoli within the body, which allows higher oxygen intake, so more ATP can be replenished, and this gives the body more energy. This tests type 1 muscle fibers. For aerobic training, this would be much different and more appropriate for a midfield player who is constantly working, having to go to the ball, rarely gets a break, and the FIT principle could be applied again. So the frequency would be much more often, so 10 times a week, as it needs to be repetitive so it can be improved. The intensity would be high, so the body definitely using no oxygen, and the time would be short, as the midfielder has a lot of quick bursts of energy, and a lot of aspects are appropriate to football. And the type, as shown, could be circuit training, testing all the aspects of the body anaerobically, and this should test type 1 muscle fibers. There are different adaptations to help with your specific sport, and they only work if you train them. There are different ones for anaerobic and aerobic. So for each system there is likely to be adaptations, aerobic or anaerobic. For the aerobic aspect of the cardiovascular system adaptations, you can train to improve your VO2 max, which is the volume of oxygen that can be utilized during intense exercise. And training this aerobically will lead to it being higher, as shown in the VO2 max diagram. It will build up higher, so you have more oxygen available for a sport like football. Cardiac hypertrophy is the thickening of the heart muscle so it can pump out more blood. This is increasing the stroke volume of each pump by the heart, so it doesn't have to beat as much, so it can increase its total cardiac output with a normal number of beats, but obviously a high stroke volume. This can be linked to VO2, as there is a limit, but you can still train it to improve it. Anaerobically, there isn't much to do with the CSV system apart from the sinoatrial node, which can increase the parasympathetic activity of the heart, which lowers the resting heart rate, which can help recovery and removal of waste products. The respiratory systems only apply to aerobic adaptations, and as it obviously involves oxygen. Ventilation is, if training was done, then the VO2 max is much higher, so during a match more oxygen can be used to enhance performance. This is also due to minute ventilation having the ability to increase by 50% to 150 litres per minute. Also, there is improved removal of waste products due to there is a higher gases exchange between capillaries and alveoli, so oxygen can be pushed around and carbon dioxide can be removed more effectively. Also, the CV adaptations, you can reduce the chance of getting any respiratory related diseases, so the oxygen being able to circulate much better. For the neuromuscular system, there are more adaptations that can be used anaerobically to do with motor units and muscle fibers. If you train often anaerobically, then you will be able to recruit and summate fast glycolytic fibers and fast oxidative glycolytic fibers, and therefore increase the power and force that is desired for football. Say a goal kick, you need to kick it further and longer up the pitch. Also, there is a decreased nervous inhibition, which is there is less nervous feedback going to the muscles, so they don't overwork and potentially rip, which could cause an injury in football. Say, like, you're nervous in a game of football, maybe you're running down the wing and you may pull your hamstring if there was a lot of nervous inhibitions, nervous feedback going to the muscles, so it avoids that. And then finally, there are cellular adaptations, which is modifications of neurotransmitters and chemical and biochemical responses. So you may have faster reflexes as a goalkeeper, maybe from a shot from close range, or if you, there's a corner in the box and it's going around, you need to kick it quickly to get it in the net, then your reflexes might be quicker. For the aerobic aspect, there are also more slow oxidative fiber recruitment for aerobic activities, and there is, say, like trying to regenerate your oxygen while the ball is down at the other end, and that improves cellular respiration in the body. And there is also increased mitochondria sizes, which is improving cellular respiration. The energy system adaptations are very similar for aerobic and anaerobic, as both are involved for most energy systems. Firstly, there are increased enzymes which cause the muscle twitches and enhance muscle twitches, so they are more efficient with ATP production, which it would be good for football, as there is a lot of high intensity, quick bursts of energy needed. For lactic acid training, it will increase the tolerance, as shown in the diagram. There is a lactate threshold, so that could be later on. So you have a higher, you can stand lactate much better, and when it starts to build up, it will start to build up later, so your muscles won't become as tired as easier. So there's more oxygen getting inside muscle cells as there is insufficient lactate buffering, and the muscles and heart being inefficient at removing lactate, which will improve through training. Also, anaerobically, there is also increased use of fats for energy, which is a long-lasting source of energy, which again is useful for football as it goes on for the full 90 minutes, and you need to have energy for all of that. And also for a quick burst of energy, there is for anaerobic, there are more stores of PC, phosphocreatine, which allows big bursts of high intensity exercise. So if you're a striker, you can run quickly when needed past the defender to get in on goal. And then for the skeletal system benefits, there are only benefits for long distance runners that use oxygen as a main source of energy, and having minimal mineral content maintain the active lifestyle needed for being long distance, and it keeps bone mass, which again could be useful for a long distance runner as well as a footballer who needs to keep the bone mass that they have, or increase it so they might be stronger in a tackle, and also less likely to be injured. Anaerobically, osteoclasts migrate to the surface of the bones, which make it more dense, and again this is relevant to and this may help them being stronger and could make them less likely to break their bones. And it helps avoid osteoporosis, which is a disease maybe to the the wrist or hip, which means they can break easily. Also, it can help osteoclasts with the remodeling of bones, and this may increase the range of movement available and the performance and a performer's health. Then finally, with cartilage, you may overtrain and have joint stiffness and the pains in joints, which is also known as osteoarthritis. Also collagen and increased tendon strength, which will massively improve flexibility. With bone tensions, increase the body's range of movements, which is again useful in football, as the keeper may need to be reaching up for the ball to catch it, or you find yourself in an unnatural position up front and you need to stretch to get the ball ahead of the defender.